All right, so this is section 3.2, Systems of Linear Inequalities. Section 3.1 was Systems of Linear Equations. So we're going to have a very similar approach here. We're going to graph the two inequalities and see where they overlap. The difference is that there's going to be shading involved this time. So we're not just looking to see where the two lines intersect and overlap like we did last section. We're looking to see where does the shading overlap. So here we go. If you feel like you know what you're doing already, go ahead and pause the video and see if you can do it without my even explaining it. So we're going to take each inequality and we're going to rewrite it into slope-intercept form, same as we did with the graphing method for equations. Okay, and then I'm going to graph this red line. Please use 3 points when graphing a line. Remember that when you go to connect those 3 points, remember solid or broken line. So now we have to decide which side of this line gets shaded. So I'm going to test my favorite point, 0, 0. You can test it in the original or this slope-intercept form. It doesn't matter. I typically do the original. So 0 is greater than or equal to 6 in the original equation, and that would be false. So if 0, 0 is false, let's just locate where 0, 0 is on the graph. If 0, 0 is false, it means it's not a solution for this red inequality, and so it should not get shaded. So all the true points, all the shaded points, are going to be on the other side of the line. Now I'm just going to draw these arrows for now instead of just shading entirely. Right? If you want to shade, you can. But we're going to be looking for where the shading overlaps of the two colors. So the blue line already is in slope-intercept form. So I'm going to just go ahead and graph that. Up to right one, up to right one. This time I'm using a dashed line. I'm going to test my favorite point again, 0, 0. And that becomes 0 is less than -1, which is also false. So if 0, 0 is false for the blue line, then the left side of the blue line is the false side and the right side of the blue line is the true side. So this right side of the blue line is the true side. Now, our final answer is where the two shadings overlap. And so you have to look for the area where the two shadings overlap. Now, I'm going to just draw this graph again. Notice that it got split up into 4 zones. So we've got like this zone 1, zone 2, zone 3, and zone 4. One of those zones will be true. Zone 1, which is up here, zone 1 only has red shading, so that's not the answer. Zone 2, which is over here, has no shading in it. Zone 3 has only blue, and so zone 4 has blue and red. That's going to be our final zone that is our shading. So what we're going to do is you're going to shade that final area and really darken it in. So if you are shading lightly in pencil or 2 different colors, you really want to darken this area in so that it's clear to me which one it is. It might also be helpful to just go back and erase any light shading you had, but that's not really necessary. As long as you darken that shaded region here, then that's good. And this is how you would leave your graph. So then I might ask you some follow-up questions like, is 4, 5 a solution? And you would look at the graph and say 4, 5. 4, 5's right here. And so yes, that is a solution because it's in the shaded region. I might ask you, is 2, 0 a solution? And you say, okay, 2, 0 is right here. And you say, no, it's not. Because it's not in the shaded region. Right? Then you might say, what about -3, 4? -3, 4 is over here. It's on a solid line, So typically when things are on a solid line, we say yes, but it's not bordering the shaded region. So this is a no. In order to be a yes point, we're looking at something like 3, 0. 3, 0, right here, 3, 0 is on a solid line. It was solid, I erased it a little bit. So 3, 0 is on a solid line, and it borders the shaded region. If you're ever unsure, what you should do is take that ordered pair, substitute it back into both inequalities, and it should work for both of them. So a point like 2, 3, 2, 3 is this point right here. 2, 3 borders the shaded region, but it is not true for the blue inequality because it's on the broken line. So points that are on a broken line, automatically you have to say no, regardless of where it is. When you talk about a solid line, you have to be careful. A solid point down here, like 3, 0, would be a yes, but this point up here is a no. So watch out for those tricky questions. All right, so let's try another one. Go ahead and pause the video and try it. So I'm going to take this first inequality, and it would become negative y less than negative x minus 1. I'll then divide everything by negative 1. When you divide, don't forget to switch the inequality sign. So this is what I'm graphing. At least 3 points to make a line, and I'm going to make it dashed. I'm going to test my favorite point, and in the original it would become 0 is less than negative 1, which is false. If 0, 0 is false, it means my shaded side is this way. Now I'm going to look at the other inequality. I'm going to skip the algebra here. Your equation should come out to be y is less than x minus 3. 3 points to make a line. It's dashed again. Testing my favorite point in the original, 0, 0. It becomes 0 is less than negative 21, which is false. So if 0, 0 is false, I'm going to shade this way, the opposite side of 0, 0. Now, where do the two shadings overlap? They don't. So in this case, we will say no solution. Right? Now you want to make sure, for me, as the teacher, that you label no solution nice and clearly. And I would actually, maybe go back and erase, right? This is a big section of erasing. You don't want me to think that you think that there are shaded regions on this graph. There are no shaded regions on this graph because there is no solution. All right, one more example. Example number 3. So example number 3 has 3 lines. Let's start with the first one. Take that and rewrite that in a slope-intercept form. I'm skipping the algebra. Hopefully you paused the video and attempted this by yourself. Down 1, right 2. I'm going to get a 4th point in here just to be more accurate. Dashed line. If I test 0, 0 in the original, 0 is less than 6. That is true. So if 0, 0 is true, here's 0, 0. We want to make sure 0, 0 is shaded. So I would be shading to this side of this line. Notice that also, I don't think I mentioned this, you can't test 0, 0 if the line goes through 0, 0. So that's the only time you can't test it. Then you have to pick something else. All right, x is greater than or equal to negative 2. You're thinking hoi vux. So that's a vertical line at negative 2 on the x-axis. You don't need 3 points for vertical and horizontal lines. This is a solid line. And the shading, if I tested 0, 0, 0 is greater than negative 2. That is true. So the shading would be to the right. So as I'm doing this, sometimes it's helpful to try to start to focus on where your shaded final region will be. I know it's not going to be up here. It's not going to be up there because that region already only has red. So sometimes I've known students to like, don't even draw any shading there because that can't possibly be the region. Maybe they'll go back and erase, some of these lines. So I'm focused right now on this region down here, right? Because that's the region so far that has red and blue. So now we're going to add in one more color. Let's go with green. So I see y is greater than -3. That's a HOI problem. So that means it's a horizontal line at -3 on the y-axis. It's solid. If I test 0, 0, 0 is greater than -3. That is true. So I would be shading up towards 0, 0 on this line. And as I'm doing this, I'm noticing this shaded green out here to the left is not having any blue or red with it. So my final shaded region, I'm gonna make it in black. Oh, you know what, let's stick with purple. Is this inside of the triangle. And the triangle will eventually intersect down here. But I'm just gonna color this in. When you have 3 lines, it typically will form a triangle. Do not get used to it being always shaded in the inside of that triangle. 1, 2, 3, 4, 5, 6. There were 7 regions created total. If we extended this graph off to the right, there's 7 total regions. It just happens to be the inside of the triangle. It could be any of the 7 regions. So don't always expect that. All right, so we are going to build off of this example tomorrow and talk about finding the vertices of that triangle. So if you want to try to find those vertices now, you can. We'll build off of that.